plenary speaker, Professor Yuanzhe Li, will arrive a bit later. And now we would like to move on to the commemorative session. Please join me in welcoming session chair, Professor Chen Jingcai of National Yangming Jiaotong University to moderate this session. Professor Cai, the floor is yours.
Good morning. Our conference chair, Professor Ji Chen, and our honorable guest, and our vice president of NTU. It's my honor to chair this session. I pay my tribute and introduce Professor David Pui to every one of you. He's now the member of National Academy of Engineering and also Regents Professor, the highest honor in University of Minnesota, and Director of Center of Particle Lab, and Director of Center for Filtration Research. Pray. Little bit trouble. Open to many files. Okay, sure. Yeah, Professor is my formal advice, PhD and master degree. And can you click next one? I don't know. Get stuck here. Okay. Yes. And he received all his degree in University of Minnesota, starting from bachelor degree in 1970, and then the master degree and PhD degree, and then he served in the particle lab as a lab manager for a long time. And when I joined his lab, he is still very young. This is the picture taken at his home when I decided to join his lab. So we all look very young at that time. So besides those positions, he is also the chair of TSI LM Fingerson and the distinguished McKnight University professor. And also in China, he was appointed as a presidential chair professor. And he received all the awards in aerosol science and technology, including the highest honor, Fuchs Memorial Award, and Fellow of AAR, Davidson Gray Award, and International Aerosol Award, so on and so forth. And also, in foreign country, he also received Einstein Professor Award from Chinese Academy of Science, Max Planck Research Award. And he has published prolifically 442 papers, including 342 journal papers. And he tried very hard to commercialize his inventions. And most notably devices, the long DNA and SMPSs, and which have been widely used for aerosol researchers, in addition to aerosol mass monitor, surface area monitor. He advised many PhD students, and many become famous chair professors, like from Taiwan, there's Professor Darren Chen, and also some work in applied material as a senior manager, and also one of his master students later became the president of University of Hong Kong, Zhang Xiang. And also he mentored many postdocs, including Sean Chen, my former PhD student, who later became the assistant professor of Virginia Commonwealth University. Of course, during those times in particle lab, we are both in paper writing and also reproductive in kids births. Every one of our students in the particular has 2 kids. Through his promotion, we also, many of our his former students received some aerosol awards, including myself. And this conference is held under the umbrella of AARA, Asian Aerosol Research Assembly. He's actually the prime mover of this 7-member association assembly, including Chinese Society of Particulology and Korea Association of Particle and Aerosol Research, and our association, Taiwan Aerosol Association for Aerosol Research. And in 1991, the first conference on pollution and health effects of airborne particles was held in National Tsinghua University in Taiwan. And next year, he also came to this conference, hosted by me, Conference on Aerosol Management Technologies in NCTU. And at the time, he encouraged the establishment of our association. So later, 1 year later, our association was founded, and next year, followed by CAPA, Korean Association, and then Chinese Association. So we will succeed his will to expand the AARA to another Southeastern country, including Vietnam and Malaysia and other SEA countries as well. And he always tried to promote research around this Asian region. This is the conference he hosted 2008 in Minnesota. We attended NATO ESH conference. And following that, he came to Taiwan to promote this conference to be held in Taiwan. So during his term as the president of IARA, International Aerosol Research Assembly, which have 18 members, he promoted again the aerosol pioneer who have made significant contributions, including Icons and many others. And at that time, I was the lab manager, the manager of the website. So we worked together to make this IRA website more complete. And there are many other aerosol pioneers, including from Japan, Koichi Inoya, Whitby from Particle Lab, and Matsuda also from Japan. And the latest one would be Sheldon Relander from US. So in order to be listed as an aerosol pioneer, you have to be a person. So it's not so easy. There are only 13 so far. So you can only give the aerosol pioneer lecture, but you cannot be listed unless you are making a very significant contribution. So Professor David Hui, he's passionate in aerosol research for 50 years, starting from 1970, more than 50 years. So we are very honored to work with him, and he also interacted globally and also with our Asian countries, and to establish an aerosol association to work together on projects and also exchange ideas. So let's welcome Professor David Pui for his commemorative speech, Reflection on 50 Years of Friendship and Collaboration on Aerosol Science and Technology. Thank you.
Well, thank you very much, Professor Tai, for giving such a comprehensive introduction of me. I feel like I don't need to say too much because you already said a lot of what I have done. But today, I'm very pleased to be in this room of leaders, graduate students, and researchers doing aerosol and environmental research. So I'm very happy to be able to share with you my talk today. I should mention that my Chinese name is Pei You Kang. I actually grew up in Hong Kong. After I graduated from high school, I actually spent 1 year at the National Taiwan University before I moved on to the US and stay in University of Minnesota all this 50-some years. And during the 50-some years, I worked with many talented students and postdocs, and also meet international scholars around the world. So I've developed a lot of friendship and collaboration on aerosol science and technology, which I would like to share with you. Now, to start out with, I'd like to quote this Landsec Commission indicating that pollution is the largest environmental cause of disease and premature death. And each year, 9 million premature deaths is due to pollution. And in some of the country, 1 in 4 deaths is due to pollution-related disease. So with that, my team has the vision of developing green technologies that benefit the sustainable environment, which will enable people and the environment to prosper together through 3 objectives. Number 1, mitigate PM 2.5, volatile organic carbons, and ozone in urban environment. Number 2, reduce greenhouse gas CO2 to mitigate global climate change. And number 3, to provide clean water to achieve water sustainability. Now, I've been very fortunate that over 35 years, I was able to work with many companies under 2 industrial consortium. One is microcontamination for semiconductor manufacturing, and the second one is the Center for Filtration Research. And over the years, a lot of graduate students came out from the lab and contributing to the society. Now, currently, I have a Center for Filtration Research, which is very successful ongoing consortia. So in fact, it is a international consortia because we have 1 company, Shigematsu from Japan, 2 companies, Samsung, LG Electronics, 3 companies in Germany, BASF, Mann & Hummel, and Freudenberg, and 4 Chinese company, Xinda, Huayuan, and Yancheng Environmental Park. And then Meidi is the latest to join, and so we're very happy that the student was able to go and convince the company to join. And then we have a large number of US company, 3M, Parker Hannifin, Cummins, and TSI. And then there are some electronic semiconductor manufacturing focused company Applied Materials, W.L. Gore, Entegris. And then we have two large end user, Boeing Commercial Airplane and Ford Motor Company. So together, we work on many topics relating to filtration research. So it will be impossible for me to describe too many research projects because I have to cover 50 years. And at the CFR, at any time, we're working on 15 different research projects. So I just want to mention that of all the projects done by the students, before they left, I want them to input their results in the form of filter performance modeling and design that the company can log on and make use of the model to design composite filter, optimize filter performance, and then extend filter life. Now, one of the things that we like to do is to create sustainable environment through developing indoor air cleaner for local control, gasoline particulate filter for source control, and then this is a large-scale air cleaning system for urban control, and then also for CO2 control. So if we can do all this well, we would create a sustainable environment for the world. Now here is the large-scale air cleaning system, and so we published the first paper 2014. Already there are many units built. Xi'an is the first one to build. This is totally driven by solar energy. So you see glass panel. So when the air inside underneath the glass panel warm up, it will be driven to the higher area in the middle. And then there's a set of filter before, so that they are filtered before the clean air coming out here. The second generation is making use of water spray, and we could use it for CO2 control. I will tell you a little bit. And then the third generation is currently deployed in Delhi. There are 2 units built, and in fact, there's a lot of press about our activity in Delhi. And Professor Sean Chen, later on, he will talk in depth about, he just came back from India. He will tell you more about that. So we also do modeling to show that within the confined area, the air can be cleaned up by more than 50%. And Dr. Chen will tell you more about this. And this is the second generation tower that make use of water spray to take out the PM 2.5. But we can introduce sodium hydroxide in the water so that when the water evaporates, sodium hydroxide can be used to remove CO2. And once again, Dr. Chen wrote a paper on this topic. Now, one of the important product of a professor is the student that he graduate. So I'm very fortunate to work with a very talented group of graduate students. There are about 30 PhD students, and the red one, the one now working at the university as a professor. And then I also work with a large group of another 30 postdoc and master students, and also scholar. Now, it's impossible for me to tell you every story about each student. I just want to show you a few as example. So these are the 7 students that I started as an assistant professor or associate professor. So the first one is the chair professor, Chunjun Cai, and then chair professor Darren Chen in their respective university. And all the others are senior director of various company. And the last one, the seventh one, Scott Ernest, is currently director of US NIOSH, Office of Construction Safety and Health. Now for postdoc, I actively recruited Shunki Che to change from heat transfer to particle technology, and he did that, and he became Dr. Lu's favorite student, and later on he became vice president of Samsung Electronics, and then later on senior vice president of Samsung Display. And then another well-known postdoc is Jing Huang. He's associate professor now at ETH Zurich. And Sean Chen, as I mentioned, he will tell you more about the air cleaning tower. And then currently, Dr. Chixing Oh is my laboratory manager, and he mentors students and staff, and working harmoniously with all of them. Now, I have also several famous master students. Zhang Xiang, he was Chancellor Professor at UC Berkeley and now President of the University of Hong Kong. Actually, we exchanged some messages just last few days. And Mike Bergen, he actually took my first class when I teach thermodynamics, and he decided that he wanted to be my student. Now he's a professor at the Georgia Tech. And there are many outstanding scholars that come to Minnesota. I just want to point out one, Wang Xianqing. He came during the time that China opened up, and he returned to become a professor. And later on, he told me that he became vice president of PetroChina. So one thing that's very important is that actually I have banners for all of this, but it's cut off by the display in here. Is it possible to move it to the bottom? I wonder. So anyway, teamwork is very important. So I try to every week to bring my students to play bowling. Now you notice that everybody picked the biggest bowling ball, and I picked the smallest one. I aim for precision, whereas students aim for power. Yeah. So yeah, maybe that's okay. Just leave it. Yeah. That's okay. Yeah. Yeah. Just leave it. Yeah. Yeah. Oh, now I cannot adjust it. I should not have changed anything. It's not working. Okay, good. So, and then we try to go to Hong Kong Noodle for lunch every 2 weeks. And oftentimes when the student return, they still ask me about Hong Kong Noodle. So here's Jing Wang when he was a postdoc. And then here is the latest student that went to Meidi. And within 3 months, he convinced his company to join as CFR company. And then every time we have big meeting, there's a huge group of people. You can recognize many of the people in here. One time we had a meeting at UCLA, and then I said that, oh, for those of you with the particle lab, I'm inviting you for lunch. So I lead the way, and I look back, there may be 100 people following me. So now what I like to do is to talk about a few of the early work. I'm very fortunate that very early on, Professor Benjamin Liu, my advisor, and I work on using a DMA to classify monodispersed aerosol of known size and known concentration because they are all singly charged using an electrometer. And with that, currently, actually, this technique become 2 ISO standard for calibrating particle number concentration and determination of particle size distribution. And I also work with George Milholland at NIST to certify 60 nanometer and 100 nanometer particle standard using this technique. So with this technique, many aerosol pioneers came to Minnesota. David Sinclair of US Atomic Energy Commission, he came with his diffusion battery of collimated hole structures. And you know the exact number of holes and the diameter of the hole so that it is possible to theoretically calculate the penetration of different size particle coming through the diffusion battery. So the smooth curves are the calculated results. And for me, I generate different size particles and then obtain the experimental penetration. You see that it has exact agreement. This is actually the first time that Einstein's first equation is proven using the aerosol technique. And the second person that came is Professor Jean Bricard of University of Paris. He came with Professor, at that time, his student, Michel Poupry, and they brought along this continuous flow CPC using alcohol, and we evaluate them, and we told TSI that it's a good instrument, and then TSI signed a licensing agreement with French Atomic Energy Commission to get 15 years of use of this patent to develop the current generation of TSI CPC. And then another pioneer is Professor Othmar Preining of University of Vienna. So he decided to invite us to provide the aerosol standard and also everybody involving in condensation particle counter like Professor Kusaka, Janicki, and at that time his student is Dr. Szymanski, and we did the calibration and wrote 2 papers, and this is the first workshop on condensation particle generator. And the next one is Professor Ken Whitby. He developed the electrical aerosol analyzer to measure particle distribution. This is bigger than the refrigerator. My friend, Professor Fessan, he liked to tell the jokes that in the afternoon, if he feels sleepy, he opened up the door. He would open up the door and then take a nap inside. And Professor Ben Liu and I later on developed this benchtop scale electrical aerosol analyzer. This is mounted inside an aircraft. And there are thousands of this sold. And this is the instrument that are used to measure atmospheric particle size distribution. And a lot of that go into determining EPA PM 2.5 standard. Now, another aerosol pioneer, Sheldon Freelander, and he convinced me to work with him to work on a workshop for nanoparticle aerosol science and technology, and we publish papers on this. And so now I'm so fortunate to work with so many aerosol pioneers. So during the time that I'm International Aerosol Research Assembly President, I decided to convince the IARA board to organize an Aerosol Pioneer website. So Professor Chin Cai, he was the secretary at that time and helped with getting the site uploaded. You can see that here are some of the aerosol pioneers. If you hit on the blue underline, you will get biography written by the nominator. And as Dr. Chai tell you that in order to be on this website, you first need to die so that there's no competition. And also the National Association, there are 17 national associations in IARA. The National Association need to endorse your nomination. So now one of the very deserving aerosol pioneer, not yet on the site, is my advisor, Professor Benjamin Liu. The reason is that Professor Liu is still very alive and active. So, but I'm very fortunate to work with him. Even as a master student, we work on a theory for aerosol neutralization, and then we developed the aerosol neutralizers using krypton-85 and polonium-210. And I also work on following my PhD study, doing unipolar charging theory for charging under low pressure free electron together with the students. And then I work with Professor Tsai and some other students on developing the sampling inlet for PM10 and PM2.5. And one of the projects that's very fun to do is with my student Chen Daren, and we work on electrospray technique. And these two papers actually receive more than 1,000 citations because we teach people how to do it. And one of the applications is that we have 12 to 15 patents, and then one of the company, Nanocopia, licensed with the university and making use of electrospray to make nano medicine. So I heard that they are doing well in developing some major reformulated drug. And of course, with Daren, as well as with Professor Heinz Fissan, we work on the nano DMA. And so this long DMA I developed during the 70s, and Daren worked on the nano size DMA. And so if you put this on the platform in here with the software and the flow rate voltage control and connect it to a CPC, this is the SMPS, that's the workhorse for measuring PM2.5 in the atmosphere. And furthermore, Professor Fissan and I, together with our students, work on the nanoparticle surface area monitor. And Professor Fissan find out that the signal in here actually represents the surface area of particle deposited in the lung. So this is, there are quite a few papers on this, although it's not a very successful commercial instrument. And then Professor Fissan and I, during one period of 7-8 years, we have a project funded by Intel to look at contamination control issue. in extreme UV lithography. At that time, they don't know what it is, what type of contamination they may have. So we work with a group of students, Professor Fissan's PhD, Christoph Asbart. He came for a couple of years as my postdoc. And guess what? Christoph Asbart, you probably see his name quite a lot because he is now the president of GAEF, the German Aerosol Association president. And during this 10-year period, we published 15 papers on EU VL contamination control and like thermophoretic repelling the contamination, and many of this reduced to industry practice. Now, with collaboration with Professor Fissan, we done a lot of things together. Heinz will give a talk later. And we are very happy that we were awarded with the Max Planck Research Award. Now, this is the highest award for engineer or scientists in Germany. So I'm happy that I received it even when I'm a little bit young at that time. And Professor Fissan and I collaborated for 40, 50 years. And so we are very good friends. In fact, he is the godfather of my daughter, Elizabeth. And also, one time during a meeting in San Francisco, several of us are eating dinner in a boathouse in San Francisco Bay. And then we find out that, hey, actually, we all have daughters about the same age. Christine and Elizabeth are my daughter. Martina is Fissan's daughter. Pupri, Celine, you know, Pupri is the one that came with Jean Bricard for the CPC. And then Kosaker's daughter, and then Vlada Szymanski's daughter, Isabella. So we suggested maybe we should send our daughter around to visit each other as our ambassador. Yes, they did that. So you see them in French Alps, in German Gardens, Austrian Alps, and Minnesota Fort Snelling. And however, they now have all grown up, and Christine is an orthopedic surgeon. Elizabeth is a nurse practitioner. Martina is a pediatrician. Celine and Isabella's a businesswoman, and Risco is an engineer. So they cannot be our ambassador. We have to be our own ambassador. So we set up a scheme that every 2 years we should visit each other. And yes, indeed, we did that. The first one, 2012, was in Kyoto. And the second one, 2 years later, in Burgundy country, drinking a lot of red wine. And then the 2017, we went to Vancouver, where we have a place there. And then 2019, we were in Berlin. So we have a lot of fun doing things together and visiting each other. And as a result of all our collaboration, TSI decided to set up a Fissan Pui TSI Award, and it's given every 4 years during the International Aerosol Conference. So this year it will be given in Athens. And we're specifically saying that the collaboration must be for engineers and researchers residing at least in 2 different continents, like Europe to Asia, US to Asia, and so on. So I hope that some of you may one day get it. I should mention that TSI set up 75,000 initially, and two years ago, I learned that they invest the fund that it has $150,000 endowment now, and maybe after we are gone in the future, it might turn into a Nobel Prize for international collaboration. So finally, I want to show you a picture of my family. Now, my daughter, Christine, my another daughter, Elizabeth, and then my son, Jonathan. And each of them give us 2 grandchildren. So we have 6 grandchildren for the family. Finally, I want to mention that my brother, Pei Zheng Kang, is actually a National Taiwan University Medical School graduate. I think he was ranked number 1 or number 2 at that time. And currently he's academician of Academia Sinica. So he went to US and become a chairman of oncology at St. Jude's Pediatric Children's Hospital. And during his time, he was able to improve the yield rate from less than 50% now to 94%. He now also collaborates with 25 children's hospitals around Asia, and each year they save thousands of children's lives. And Fortune magazine, a few months ago, named him as the world's 50 greatest leaders. And he's ranked number 30. So I like to joke with him that I must have been ranked number 51. Okay, so that's all that I have. And I like to encourage after the conference that you consider submitting paper to the AAQR AAC special issue, and there's a section for collection of the paper during this commemorative session. So thank you very much. I appreciate you listening to my talk. Yeah, thank you.
Yeah, thank you, Professor Pui, for giving us such inspiring joy of international collaboration. And we often are inspired by Professor Pui. So at the age of 73, he's still working very hard on publishing papers. We are writing papers together. We create some idea together. Yeah, I'd like to ask the audience if you have any questions for Professor Pui before the break. Okay.
We have a question over there.
Oh, yes, please. Yes. Professor Wu, right? Wu Changfu,
Yes,
from NTU.
I'm Zhang Fu from National Taiwan University, and thank you for sharing your journey on aerial science. My question is that many people are working on the sensing technology, the local sensors. Can you share your view on this technology, the local sensors?
Oh, okay. Yeah, I should mention that my second PhD student, Yang Yi, he went to Applied Material and become senior directors, and he developed many plasma etcher, CVD deposition chamber, and so on, with 100 patents. And then he took an early retirement. Guess what? We are now collaborating together. And during the last 3 years, he was able to make a sensor, very tiny, you can clip on the lapel to measure aerosol concentration. And also recently, he was able to develop that into a bioaerosol sensor with only less than $100 worth of parts, although he needs to do a lot of theory, a lot of software to make it work. But I don't have time to show you. You can see that he is looking the fluorescent signal from bioaerosol. So using different filters, he is able to block out all the light scattering, white light scattering, and focus only on fluorescent light scattering. And using different wavelength, he can even identify what type of virus it is. So yes, another PhD student, he's developing a environmental chamber with controlled temperature, controlled humidity to evaluate many sensors together. Because with the low-cost sensor, how well they perform is an important question, so we like to do that. Did I answer my question, your question? Okay, yeah, thank you.
No, thank you. Any other questions? Okay, yeah, please. Can you identify yourself first?
Okay, KJ Zhuang from Taipei Medical University. Thank you for your presentation. It's wonderful. My question is, now we have air monitoring stations around the world, and this station usually run by EPA, but that's for outdoor air pollution. But so far, the indoor air pollution is also a very important issue because we spend a lot of time indoor. So can we do the same thing for the indoor air pollution, like a network based on existing outdoor air pollution station? I mean, maybe we can do some connection from those outdoor air pollution to indoor and do something. That's my stupid idea. What's your opinion? Thank you.
Yeah, thank you. First, I'd like to tell you that I was sitting on the National Academy of Engineering committee to organize a workshop for indoor air quality. Maybe I can give it to Chin. It's free to download. We invited 18 scholars to talk about that topics. But at my Center for Filtration Research, we have actually launched several indoor air quality projects. One project is to, during the COVID-19, we want to see how ventilation flow and can affect the room cleanliness. So in fact, we have a model, we put it on the open website for everybody to use it. The website is cfr.umn.edu. So you can go in and change the ventilation flow to see how quickly the aerosol decay. Yeah. But the other topic that is very interesting is that you know that if you charge the aerosol particle unipolarly, the aerosol particle will expand because they repel each other. And when they get close to the wall, they will be attracted to the wall by the image force effect. So Francisco Romay, my number 4 student, he's working now in my lab. He purchased some Amazon ionizer. And then in a room, he turned on the ionizer. He can either do bipolar ionizer charging or unipolar ionizer charging. But the impressive thing is that if he turned on unipolar charging, the concentration in the room can decay from 100% to 20% in just 90 minutes. So I told him that, wow, this is great. We